Gibbs phase rule. This you know F. Then what happens? यही है ना? ये पढ़ा कि नहीं रे? F is what?
Degree of freedom.
इसको फ्रीडम क्या है? उसको freedom. Is it a temperature and pressure? Freedom means these two components, metamorphic components. वो थोड़ा अंग्रेज आदमी करके डाल देते हैं कुछ pressure. What is this C component? I told you. C is component.
Component.
C is component.
Yes, sir.
Chemical.
Minimum.
Minimum number of components. Phi is phi और psi बोलते हैं, क्या बोलते हैं?
Phase.
Phase. Mineral phases.
Yes, sir.
2 तो है लिखा है. ठीक है. These things you must have read, ना? मैं आपको एक क्वेश्चन पूछता हूँ, आप बताइए. Suppose in water system, you know, pressure and temperature is there. So here is your ice. This is water. This is gas, vapor. Vapor. If temperature increases, the water changes its phase. Initially, so this will be 0. This will be 100. So if I take a point here, number 1 point. Number 1 point. Can you tell me how many? What is F? F is 2. Pressure and temperature. 2. They are fixed. Then what is C? Component, chemical component I am telling. Water. Chemical component is water.
One.
H2O. So C is equal to 1.
Yes, sir.
Then phase is equal to?
One.
Phase is equal to 1. Ice only. And so is this equation satisfied? 2 is equal to 1 minus 1 plus 2. ठीक है रे? ठीक है? ठीक है ना? ना इधर करेंगे तो same thing will happen. इधर लेंगे तो same thing will happen. और इधर लेंगे तो 2.2 में 0.2 में how many? F is there. F will be how many? C will be how many? Phase will be how many? And C is equal to 1. C is equal to 1. Water. And how about the phase? 2. Phase is equal to 2. So how it will be?
1, sir.
So 1 minus 2 plus 2. So F is equal to what?
1.
F is equal to what? Means what? What does it mean? Huh? So this point, that is why the lines, you know, separating two phases is called a univariant curve. Huh? Univariant. Means if you are fixing the pressure is this much, then temperature is automatically fixed. You cannot increase the temperature. Only one freedom. That is why the freedom term came. Similarly, this point also. F is equal to 1. Univariant. Single variation. But you must have read. Huh? I am not going further details. Now you come to mineralogy. Can I remove it? Okay. So Goldfield mineral phase rule. Huh? Let us take an example. Same. Principle is same. So which mineral phase we will adopt? This side is pressure. This side is temperature. So this side I am writing 3.7. Huh? This side I am writing kilobar. Huh? This side is 500 degrees. Yeah. Take a point here. इसे लिखो ऐसे Now this is kyanite. This is andalusite. This side is sylvanite. Sylvanite. The temperature and pressure point you should remember. Many times comes in the exam. So, if I take a point here, number 1, how many phases are there? One phase, first start with component. Component is how many? These 3, they are all aluminum silicate. No? So it has this component, only one component. So component is 1. Here how many phases are there? Phases 1. So you apply this equation. Here, what is the degree of freedom now? 1 minus 1 plus 2. So F is equal to 2. So temperature and pressure, you can vary both. So this point is a bivariant point. Any point in this field is bivariant. Now how about these points? This point, this point. These are all bivariant points. Bivariant point. This is also bivariant point. Bivariant point. Understood? Now how about this? This. Here how many phases are there? So phases are 2. Because this is a transition from kyanite to sillimanite. So how many components? Component is 1. So how many? F is equal to how much? 1. That means if pressure is fixed, temperature is also fixed. Only one variation you can make, either pressure or temperature. So this point is a univariant point. Univariant point. And this one, so this one is also univariant. This one univariant. Univariant point. Now how about these triple junctions? Here, where I will change. So point number 3. Point number 3. How many components is 1? Phase is 3 plus 2. So F is equal to 0. So here there is no degree of freedom or invariant point. Invariant point. You understand the meaning of invariant? Invariant point indicates there is no scope for changing pressure and temperature. Suppose you are here, all the 3 minerals will crystallize, occur together. If you little change pressure and temperature, either it will go into this field or along this line. So those 3 phases will not coexist. That is why it is an invariant point. If you want to get 3 phases, you have to keep it there. Pressure and temperature is fixed. But along this line where phase change is taking place, only one variation you can make. Other one is fixed. Here, both variations you can make. Till then you will get the same phase. This point must be clear, huh? If that is the case, now you tell me how many variations will be there here? How many degree of freedom? 2. These are all bivariant points. Within the field, huh? और जब ये यहाँ जाएंगे only one. So when you changing from chloride to biotite, chloride zone to biotite in zone you will go. So there will be one only univariant point. So this point, univariant point, this is your isograde. Isograde. Chloride to biotite. So these are your isogrades, isn't it? Univariant lines are isograde. Isograde. तो एक फेज से दूसरा फेज हम जा रहे हैं. So that is an isograde by definition. अभी तो ठीक है ना, ठीक है। नाउ मैं थोड़ा इसको मिटाता हूँ, बिकॉज वी विल बी यूजिंग देम। So now chloride zone, what is telling, you take a point here, इस जगह में पॉइंट लो P1. So this is a very narrow range of temperature and pressure. Point 1. What I will write? Narrow P and T. Pressure temperature variation is not much. उसी जोन का you are finding those minerals. How these minerals can be shown? Let us only try with AKF diagram. AKF. So we are representing from this place a single pressure and temperature. Now, what are the minerals I have told you? One is muscovite, second one is chloride, third one is pyrophyllite, fourth one is your. So where will be the muscovite? ये होगा pyrophyllite. Just like kyanite, sillimanite, andalusite, ये pyrophyllite वही है, low grade में वही occur करता है. So muscovite will be somewhere here. MS I will write muscovite. Where will be the chloride? Chloride will be here. ये पूरा एक जोन है क्लोराइड. दिस इज क्लोराइड. मेरा बात समझा कि नहीं समझा? Where only potash feldspar? पोटाश फेल्डस्पार. ये तीनों इतना ही लो. So these minerals are in equilibrium. So pyrophyllite, PPR or PLR. Pyrophyllite just look. शॉर्ट फॉर्म में क्या लिखता है उसको? PRL ना? या PRF लिखता है क्या? Pyrophyllite तो देख लेंगे बाद में. Now you have muscovite, chloride, K feldspar. So these are the minerals. Now to say them they are in the equilibrium, you know. To say they are in equilibrium. They are in equilibrium. तो हम क्या करेंगे? Now we will join by these tie lines. मैं एक tie line join करता हूँ ऐसा. अब tie line join करो. Muscovite to chloride, chloride to potash feldspar. Others are joined. Muscovite ये join है, ये join है, ये join है. So these are the tie lines. Draw tie lines. Draw tie lines. To say they are in equilibrium. Tie lines is a line which joins to equilibrium phase. Now, just a minute. Fourth, plot the protolith. Protolith, pelitic rock. Pelitic rock. वो pelitic rock आप प्लॉट करेंगे. So this will be like this. ऐसा ऐसा प्लॉट करो. Approximately I'm doing, or I pelitic rock. You remember the original diagram I have given? Pelitic rock कहाँ डालते हैं? Pelitic rock. What will be quartzo-feldspathic rock? Here will be calcareous rock. Remember that one? Huh? So pelitic rocks will be here. What is that? This must see if I say, what does this point indicate? This indicates the pelitic rock which are rich with alumina. If you say this point, this is rich with iron and magnesium. You have to follow this point. And if I say this part, this is rich with potash. That is why this spread is there. This will not come as a single point. Just like the minerals. Minerals has fixed composition. But the pelitic rock may vary in the composition. So how much variation? It will not cover the entire field. So suppose आप यहाँ तक ले जाते हैं. What it will produce? Only aluminium. This cannot be a pelitic rock. So pelitic rock has a composition which will fall here. मेरा बात समझा कि नहीं समझा? Now this moscovite थोड़ा आप लिख के रखो. Moscovite में 5th point है. Moscovite is phangite in composition. What is phangite? Moscovite में पोटेशियम एल्युमिनियम होता है, और phangite में क्या होता है? मैग्नीशियम आता है, and sometimes iron. ये आता है. That is why वो जो moscovite एक पॉइंट ना दिखा के वो दिखाता है ऐसा. This is the phangite moscovite. ये it's not the pure moscovite. It has some magnesium and iron in it. That is why moscovite is phangite in composition. It has magnesium and iron in solid solution. इसके अंदर रहता है mostly magnesium but little iron. Remember this point, huh? ठीक है. सपोज आई आस्क यू, मेरा एक पेलिटिक रॉक है इधर, यहाँ पेलिटिक रॉक, एक रॉक का पेलिटिक रॉक का कंपोजिशन इधर पड़ा है. पॉइंट नंबर 1 6. पॉइंट नंबर 1. पॉइंट नंबर 1. My question is, will all the minerals be available in that rock? कौन सा मिनरल है? Pyrophyllite, muscovite, chlorite, potash phosphor, all of them will be available there in that rock. Question is, point number 1, will all the minerals be available? मेरे बात समझा? Will the all minerals available? Available? Point is that. Answer is no. Answer is no. Which mineral will be available? Chloride, potash phosphor, or what else will be there? This one though we have not defined. These two minerals will be there. क्योंकि ये इसका इसी फील्ड में रहता है. ये पूरा क्लोराइड है ना, यहाँ से यहाँ तक एवरीथिंग इज क्लोराइड. ये भी क्लोराइड है, ये यहाँ तक क्लोराइड है. सो क्लोराइड एंड पोटाश फेल्डस्पाथ, दीज आर द टू फेजेस. सपोज आई से पॉइंट नंबर 2 पॉइंट नंबर 2 में क्या मिलेगा? नंबर 7 2 में क्या मिलेगा?
Muscovite chloride.
You understood how to find out? So Muscovite मिलेगा, फेंगाइट, क्लोराइड एंड पोटाश फेल्डस्पार. So point number 2 will be Muscovite, chloride plus potash feldspar. So these are the use of the tie lines. They define, you know, a particular composition, what type of mineral phases will develop. क्लोराइड जोन इसका मतलब नहीं है सब मिनरल सब जगह में रहेंगे. So it depends on the parent rock composition. So parent rock composition कैसे गाइड करता है कौन सा मिनरल किधर है. So suppose बारोवियन जोन वी आर टेलिंग क्लोराइड, इसका मतलब क्या है अभी समझ में आएगा आपको. बट वहाँ पोटाश फेल्डस्पार सब जगह में नहीं मिलेगा या दूसरा मिनरल सब जगह पे नहीं मिलेगा. सपोज यहाँ से मैं एक ले लिया. सो व्हाट मिनरल विल गेट? पॉइंट नंबर 3 में पायरोफिलाइट मिलेगा, देन मस्कोवाइट मिलेगा, क्लोराइड मिलेगा. बट क्या नहीं मिलेगा? पोटाश फेल्डस्पार नहीं मिलेगा. मेरा बात समझा कि नहीं समझा? तो आउट ऑफ दिस थ्री अच्छा एक सपोज आई एम टेकिंग ए पॉइंट हियर ऑन द टाई लाइन इटसेल्फ, यहां ले लेता हूं तो इधर मस्कोवाइट क्लोराइड मिलेंगे. मस्कोवाइट क्लोराइड सपोज टाई लाइन के ऑन द टाई लाइन 8 टाई लाइन ऑन द टाई लाइन मस्कोवाइट और क्लोराइड, उधर मोर मस्कोवाइट और मोर क्लोराइड. That also you can decide. Suppose this point is this side, more muscovite will be available. If it is this side, more chloride will be available. मेरा बात समझा कि नहीं समझा? Similarly on this line, potash feldspar chloride. So this is the use of tie lines, you know. मेरा बात समझा? Now out of all these mineral phases, which is very common, you see the mineral assemblages. क्लोराइड, क्लोराइड सब में मिलता है इसलिए उसको क्लोराइड जोन बोलते हैं. वो मिस नहीं करेंगे आप, वो इंडेक्स मिनरल हो जाता है. वॉट एवर कंपोजिशन इट मे बी यू विल गेट क्लोराइड. देखो बट पोटाश फेल्डस्पार वो नहीं मिलेगा, मॉस्कोवाइट भी नहीं मिल सकता, सेरिसाइट भी नहीं मिल सकता ऑलवेज, but chloride मिलेगा. That is why so chloride is available in all the assemblages, in all assemblages. That is why it is called chloride zone. In chloride zone, suppose somebody asks sometimes muscovite is not available. क्या रीजन है? मस्कोवाइट तो मिलना चाहिए, तो एसेंस मिनरल असेंबलेजेस में आता है, क्यों नहीं मिलता है मस्कोवाइट? नाउ आंसर इज विथ यू. मे बी टू मच ferruginous, the rock is more ferruginous, that will be the answer. If this diagram will tell you